Hello grade 10 students, welcome back to my YouTube channel. So this is part 2 of the video that I made for module 6, which was about finding the nth term of a geometric sequence. So this is the continuation. We will have finding the geometric means. So stay tuned, learn with me as I tackle geometric means. Now let's have the sequence 3, 6, 12, 24, and 48. So, is the given a geometric sequence? The answer is a big yes. This is a geometric sequence. So, this is a geometric sequence because it has a common ratio. And what is the common ratio for this? The common ratio is 2. Because you'll have 6 divided by 3 is 2. Now, 3 and 48 are what we call geometric extremes. So they are called our geometric extremes, the first and the last terms. Geometric extremes. And 6, 12, and 24 are what we call geometric means. So if you will say geometric means, these are actually the terms that are found between any two non-consecutive terms of a geometric sequence. So, if you are taking this into consideration, 6 is the geometric mean of 3 and 12. 12 is the geometric mean of 6 and 24. And 24 is the geometric mean of 12 and 48. Or 12 and 24 are the geometric means of 6 and 48. So if you'll say geometric means again, these are actually the terms in between, or the terms found between two non-consecutive terms of a geometric sequence. Now let us consider this task. Find the indicated geometric means of the following first and last terms of geometric sequences. So let's have number 1, 3, and 8. So 3 is our first term, and 8 is our last term, and we need to insert one geometric mean. So in this case, we are going to write the first term, then you're going to insert, or we will be making one blank, that stands for one arithmetic mean that we need to insert, then write 8. So to be able to give the geometric mean of 3 and 8, we need to look for the common ratio. And to solve for the common ratio, we will always go back to our formula, which is a sub n is equal to a sub 1 r to the exponent of n minus 1. So in this case, our a sub n, or our last term, is 8. Our a sub 1 is 3. Do we have r? We don't have r, because r can be solved only if the two terms are consecutive. So, write r, because we don't have r. Our n, how many terms do we have? 1, 2, 3. So, we have 3 terms minus 1. So, simplify it further. Copy 8, then 3. R to the exponent of 3 minus 1 is 2. Our target is to solve for R. Therefore, we need to eliminate the numerical coefficient of R, which is 3. And that is possible only by dividing both sides of the equation by 3. So you will have 8 divided by 3 is equal to 3 r squared all over 3. So you cancel 3. Then you can rewrite it in this form. R squared is equal to 8 over 3. Can we divide 8 by 3? No. R has an exponent of 2. And we need to solve for R only. Therefore, we need to eliminate this. We need to eliminate our exponent here too. And that is possible only when we get the square root of your r square. So get the square root on both sides of the equation. It is square root because the exponent of r is 2. If this is 3, so you'll have cube root. If this is 4, you will have the fourth root. Is equal to the square root of 8 over 3. Cancel. R is equal to the square root of 8 over 3. Okay? And then you can still simplify it further. This is actually equivalent to a square root of 8 over the square root of 3. Do we have a square root of 8? We don't have a square root of 8. However, 8 can be factored. So I'll just continue the solution here. I hope you follow. 8 has factors wherein one of them has square root. The factors of 8 that has square root are 4 times 2. So you'll have the square root of 4 times 2 all over the square root of 3. We don't have a square root of 3, right? So just leave it there. What is the square root of 4? The square root of 4 is 2. So 2 is already the square root of 4. So it's already outside the radical sign. Then, do we have a square root of 2? We don't have. So copy square root of 2. Over the square root of 3. So this is our value of r. However, this is not yet done. It is because the denominator has radical sign. If you try to recall your second year lesson or your grade 8 lesson in mathematics, you can remember it's found there that we need to rationalize our denominator. So your fraction must be free from a radical sign in the denominator. So by rationalization, I will just write the continuation here. By rationalization, you will have 2 the square root of 2 over the square root of 3. Multiply it by the denominator. The square root of 3 over the square root of 3. Then simplify. 2 is square root of 2 times square root of 3 is square root of 6 over the square root of 3 times square root of 3 is the square root of 9. Let us simplify. 2, copy. Do we have the square root of 6? No. 6 has no factors that has square root, so you copy square root of 6. Over, what is square root of 9? 3. So this is now our common ratio. This is our common ratio. But the question is, are we done? We are not yet done. We just solved for the common ratio, and this is really very long because I'm trying to make it step by step. I'm presenting it step by step. So if you have hard time getting the process, you can always rewatch the video so that you can really understand it clearly because the solution is really long. I understand that. So this time, you multiply this term to our r. Okay? So we will multiply this to our r to get the geometric mean. So, where I'm going to write this? Maybe I'm going to write it here. So you will have 3. So I hope you follow. Times 2 is square root of 6 over 3. We can cancel 3 here because 3 will be multiplied here in the numerator. Because it's a whole number. So 3 times 2 is 6. Divided by 3 is 2. Or you can just cancel. You cancel. So what is left is 2 the square root of 6. Okay? So that is how you do it, or that is how you solve the geometric mean. You solve for the common ratio, then after that, you multiply the common ratio to the first known term, and that's it. But actually, there is a shortcut here. There is a shortcut. But the shortcut is applicable only if... Okay, I'll erase everything now. The shortcut is applicable only if you will be getting one geometric mean between the two terms. It's only applicable if you will solve for one geometric mean only. Meaning, if it's not one geometric mean, you really need to do the whole process. But if it's like this, you can simply get the geometric mean by getting the square root of the product. So the geometric mean, the shortcut of the geometric mean, this is if there's only one, okay? There's only one. This is how you will do it. Is it equal to the square root of their product? So 3 times 8, 3 times 8. So this is the shortcut, is equal to the square root of 24. We don't have a square root of 24. However, we can factor 24. The factors of 24 are, 8 times 3. What else? 6 times 4. What else? 12 times 2. So these are the three pairs of factors for 24. Now, you're going to choose the pair that has a square root. 8 has no square root. 3 has no square root. 12 has no square root. 2 has no square root. 6 has no square root. 4 has a square root, right? So you will be choosing this pair. So you will have the square root of, you substitute this with 6 times 4. What is the square root of 6? We don't have. So you copy square root of 6. What is the square root of 4? The square root of 4 is 2. Because the square root of the number is the number that if multiplied by itself would equal to the number. Like for example, the square root of 4 is 2. Why 2? Because 2 times 2 is 4. So the answer, the geometric mean, is 2 square root of 6. We have the same answer, right? But the process is short. Again, I'll repeat it. This process is applicable only when you will be getting one geometric mean between two terms, non-consecutive terms, okay? But if there will be more than one geometric mean in between them, you really need to do the whole process. Like, you start solving for the common ratio, then after that, proceed to multiplication. Okay? Now, let's proceed to number 2. We're given 3 halves and 3 eighths. We need to insert 1. So if you're going to illustrate it, you'll have 3 over 2. Then make a blank. And then 3 eighths. Good thing, we'll be looking for one geometric mean only. So that means we can use the shortcut. So, geometric mean is equal to the square root of the product. So you will have 3 halves times 3 eighths. Okay? So that is the square root of 3 times 3. Numerator to numerator, that's 9 over 2 times 8 is 16. Right? Simplify further. What is the square root of 9? The square root of 9 is 3. What is the square root of 16? 4. So our geometric mean is 3/4. That simple. Now let's have number 3. We're given 36 and 9 over 64. We're going to insert 3 geometric means. So to illustrate it, you'll have 36. Then we'll be making 3 blanks. 1, 2, 3, and then 9 over 64. In this case, there are more than. We will be looking for 3 arithmetic means between non-consecutive terms. Therefore, we cannot use the shortcut here, but we really need to solve for the common ratio. So use the formula a sub n is equal to a sub 1 r to the exponent of n minus 1. What is our a sub n? The last term, 9 over 64. What is our a sub 1? We have 36. We don't have our r, so you copy r to the exponent of what is our n. How many terms are there? 1, 2, 3, 4, 5. So our n is 5 minus 1. Simplify further. 9 over 64 is equal to 36 times r to the exponent of 4. Our target is to solve for r. Therefore, we need to get rid of 36. And how is that possible? That is possible by dividing both sides by 36 or by multiplying. We can do it by multiplying the whole equation by 1 over 36. Okay? So 1 over 36 will be distributed to both sides of the equation. So 9, so this will become 9 over 64 times 1 over 36 is equal to 1 over 36 times 36 r exponent of 4. Okay? So apply cancellation so that you'll not be dealing with big numbers. 9 and 36 can be cancelled. So 9 divided by 9 is 1. 36 divided by 9 is 4. On the other side, you will have 36 divided by 36 because this is over 1. 36 is over 1 because it's a whole number. So 36 and 36 can be cancelled. So to simplify further, I'll just be writing it here. You will have 1 times 1 is 1 over 64 times 4. So that will be 16 carry 1, 256. Okay? 64 times 4, you have 16, 24, 256 is equal to r to the exponent of 4. Okay, now, we want r only, and r has an exponent of 4. So, that means we will be getting the fourth root. So, you will be getting the fourth root of r exponent of 4. It's fourth root, kaya para ma-cancel ang 4. Para matanggal yung 4, ang exponent na 4, you need to get a fourth root. Is equal to the fourth root also of the other side. 1 over 256. Okay? Cancel. Cancel. R is equal to, what is the fourth root of 1? What is that number that when you multiply it by itself, it is always equal to 1. So, of course, the answer to that is 1. So, the fourth root of 1 is 1, of course. How about the fourth root of 256? So, let us try 4. Let's check. 4 times 4, 16 times 4, 64. 64 times 4. Okay? 64 times 4 is 256. Therefore, the fourth root of 256 is 4. So our r, let me just write it here. Our r is 1/4. So this is our value of r, 1/4. After that, this will be multiplied to our non-term. So you will have 36 times 1/4. So that will be 36 times 1/4 is equal to, you multiply your 36 to the numerator. 36 times 1 is 36 divided by copy 4. 36 divided by 4 is 9. 9, right? Then you will have 9 times 1/4. So 9 times 1 is 9. Copy the denominator 4. So write 9 over 4. Then 9 over 4, where I'm going to write this. So I'll just erase this. Then you will have 9 over 4 times 1/4 is equal to 9 times 9. 9 times 1 rather is 9 over 4 times 4 is 16. So 9 over 16. So our geometric means are the following. 9, 9 over 4, 9 over 16. So how many geometric means do we have? We have 3 geometric means. Okay? So this is our first geometric mean, second geometric mean, third geometric mean. And how many terms are there? 5 terms. So what is our first term? 36. Second term is 9. Fourth term is 9 over 16. Now for our fourth example, let's have 2x times 54x to the exponent of 4. We're going to insert 2 geometric means. So to illustrate that, you'll have 2x, then make 2 blanks, then 54 times x to the exponent of 4. Okay? So we cannot use the shortcut here since there are 2 arithmetic means unknown. So we will be using the formula a sub n is equal to a sub 1 r to the exponent of n minus 1. By substitution, you will have 54 x to the exponent of 4 is equal to, first term, 2x times r to the exponent of, what is our n? 1, 2, 3, 4. There are 4 terms, 4 minus 1. Simplify further. 54 x to the exponent of 4 is equal to 2x. R to the exponent of 4 minus 1 is 3. Our target is to get r only. Therefore, we need to remove 2x. Divide both sides by 2x. So 54 x to the exponent of 4 divided by 2x is equal to 2x r cubed over 2x. Cancel. You can cancel that. Cancel that. On the other side, you will have 54 divided by 2. 54 divided by 2 is how much? 27. So 54 divided by 2 is 27. Then x to the exponent of 4 minus 1. In the law of exponent, so I don't need to review this since you're already grade 10. So in the law of exponent, you need to subtract the exponents of the variables. 4, this is understood to have 1. 4 minus 1 is 3. Is equal to r cubed. We need r, therefore we need to get the cube root. So you will have cube root, do not forget to write 3 here, cube root of 27, x cubed is equal to cube root of r cubed. Cancel, cancel. You will have r is equal to, what is the cube root of 27? What is that number that when you multiply it by itself 3 times, the result is 27? Let's try 3. 3 times 3 is 9 times 3, 27. So cube root of 27 is 3. Cube root of x cubed is x, because x times x, x squared, times x is x cubed. So cancel. Okay? So r is equal to 3x. You multiply 2x times 3x equals 2 times 3, 6, copy x. Add exponents. 1 plus 1, 2. Okay? Then 6x squared times your r, 3x, is equal to 6 times 3, 18. X to the exponent of 2 plus 1 is 3. So you'll have 18x cubed. There you have it, guys. We're done with Module 6 for Quarter 1 of Mathematics 10. Thank you very much for bearing with me. I hope that you have learned something from me today. So that's how you will find the geometric means of given geometric sequences. So good luck in answering your modules and answering the exercises of your modules. So please watch, like, and share this video to your friends because this could be a help also to them. And don't forget to subscribe so that you will be notified whenever I will have new uploads. So that's for now. Thank you very much, Mr. Bulactin, once again.